Assalamu alaikum everyone. This is the 8th lecture for CS 116 Object Oriented Programming. So let's begin. Last time we discussed different uses of underscores in Python. Two specific cases were name mangling and emulating access specifiers. We discussed that access specifiers, they are not directly supported in Python, but some underscore conventions can be used to emulate them. Today I'll show you how you can list attributes and methods for a user-defined class. And there you'll see some surprising results. Then we'll come to dunder methods. We know that these can be represented using that underscore convention as we discussed in the last class. And we'll see one specific case or one specific dunder method, that's the initiator method. And this method is used as a constructor in Python. So we'll see what constructors are. Okay, now let's define a new class called fraction. I'll be using this class as example throughout in today's lecture. So this is the class definition. Class is the keyword, fraction is the name of my class, and this class will simply store a numeric fraction. So it should have at least two variables, numerator and denominator, and then I'll be defining some appropriate methods to access and manipulate these variables. Up till now, we have seen a couple of methods by which we can define variables. Now, the first option that I have here is that I can make my variables class variables. Like I start defining the attributes here right after this class definition, and those attributes they become class variables, and when you access the same attributes using this operator, this dot operator, they become instance variables as well. But this I will not use, because the problem with this approach is that those class variables, they are made, they have been defined, but we rarely use them in the methods, right? So that's just merely wasting space. So I won't go for that approach. I'll start defining the methods directly. Now this is the first method that I am defining. As you can see, it's a setter method, and it is easily understandable. It contains two parameters, self, which is the essential argument, which is replaced by object's name later, and x is the value that I intend to assign to my instance variable numerator. So self.numerator is my first instance variable, and x will be assigned to it when this method is called. Here's the second setter method for denominator. Now, if you remember, I told you that one advantage of using setter methods is that we can put some limit checking on the input provided by the user. So here I'll do that. Denominator, one problem with denominator is that if denominator is 0, then the value becomes infinity. It's no longer you cannot represent it now using the integer values in Python. So what I'm doing here is I'm putting a check here that if user passes a 0 for y, then we'll display an error message, and then we'll set that denominator to some default value. So if y is not equal to 0, then I'll do the regular assignment, like I'll assign y to my instance variable self.denominator. Otherwise, I'll display this message, invalid value setting to 1 instead. And after this, I'll set this instance variable to a default value of 1. So that means if user passes a value other than 0, then that's fine. And if it's a 0, then denominator will be set to 1 automatically, right? Here is a getter method, a combined getter method for both numerator and denominator. It will simply return these two instance variables as a tuple. Okay, I'm adding one more function, convert decimal. This will simply convert this fraction into decimal, and that fraction will be returned to the caller. So this is a simple statement. It will divide numerator and denominator, and the resulting float value will be returned to the caller. So there is nothing new except for that check in that setter function for denominator. So let's quickly run some test code. Here I am defining first instance of this class fraction f1. I'm setting its numerator to 4. I'm setting its denominator to 10, and then I'm simply printing whatever I have stored. So get fraction will return me those values for numerator and denominator, that is 4 and 10 as tuple, and that will be printed. So I expect some output here. Okay, this is what I expected. And then I can call this convert decimal function, and this will simply print, this should simply print 0.4, and here is 0.4, right? So I hope there is nothing difficult here. I just want you to recall one more thing, that here if I try calling get fraction method before calling the setters, that will generate error, because my instance variables, they are actually created when I'm calling these setter methods, right? So if I try calling get fraction before setting them, since they are not class variables in my class, so that will generate error. Let me instantiate one more object f2 of the same class fraction, and let's see that check that we placed in set denominator method. Now here I'm setting numerator to 9, which is perfectly fine, and I'm setting denominator to 0. So according to our code, now it should not place 0 in that instance variable self.denominator. Instead, it should place a 1 there, and it should display some error message. Okay, this is the output that we expected. Now, if I print this fraction using this get fraction method, then it should print 9, 1 as a tuple. So here it is. Okay, this is the first thing that I promised to show you today. Like, how can we list class attributes and methods? For this, we'll use a built-in function directory, or dir, simply dir, and whatever class name or object name that you write inside these round parentheses. This function will list all the class attributes and method for that entity, right? So let's try this on this class fraction. I can write this dir and then name of my class in round parentheses, and this is the output that it generates. Okay, now this is something unexpected, because these are a lot of methods, and we did not define this much methods in our class fraction. So now let's see from where these are coming and where our actual methods lie in this whole list. Okay, now these yellow highlighted 5 methods, these are the only methods that we actually defined in our class. The remaining weird looking methods, they are actually the render methods. I hope you remember this underscore convention from last class. What these renders do and where they are coming, we'll discuss that shortly. Now, one thing that I want you to notice here is that here only the methods are listed. Like, if you see the yellow highlights, only the methods that we defined in the fraction class are listed. We did not define any class attributes. The 2 attributes that we defined, they were instance attributes. So those instance attributes, they are not listed here because I ran this dir function on class, not on any object. So therefore, it does not contain, since our class did not have any class attributes, so we cannot see any attributes in this list. Sorry, there are only 4 methods. I mistakenly just said 5 methods. So 4 methods: convert decimal, get fraction, set denominator, and set numerator. Now let's run the same function on the object f1, right? Last time we ran it on the class itself, and now we want to execute it for this specific object f1. Now let's see what difference we get. This is the statement dir and then f1, and this is the output that we get. Now here in this output, first let's find out where our actual methods n variables are. Now this is the list, the yellow highlighted one. Here you can see all the methods. Convert decimal was a method. Denominator was an instance attribute. And since we are running this dir function on an objects, therefore this instance attribute is visible here. It was not visible when we ran the same function on that class fraction. Then get fraction is again a method. Numerator is the instance attribute. Set denominator and set numerator, they are also methods. So here the difference is that this time the listing contains the instance attributes too, which were not there in the last example, right? uh, some of you might be thinking that when we talked about namespace concept for objects, I told you that these methods, they are actually not present in the namespace of an object. They only reside in the namespace, in the main namespace or in classes namespace. And whenever an object calls a method, these methods, they are executed from there. But they are here in the listing because an object inherits all the attributes and methods of its class. So basically they are shown here because they are actually inherited from the class. They are not actually defined in an object's namespace. They have been defined in class's blueprint, but since an object inherits everything from a class, therefore they are included in the listing here. Now let's see from where those extra dunder methods were coming. They have been put there by Python itself, right? So what Python does, it uh, automatically adds a set of functionality, a set of default functionality to every user defined class, right? And one thing that Python does to achieve that is that it automatically inherits a user defined class from a base class called object. The object class is a base class, is a built-in base class that holds attributes and methods that should be part of every class. So since our class is invisibly inheriting from this class, so all those render methods, they were shown in our listing as well, right? And we'll explore these render methods, not all of them, but the most commonly used one in different topics. And today we'll only discuss, as I told you earlier, just one of them, that is the init method. Now what we can do, we can just override those methods and then we can write our own custom code. And I'll show you how to do that today. Now let's quickly see what dunder methods are. Dunder methods, these are methods we know by convention how we recognize them because of those underscores. We place double underscore before the name of the method and we place another pair of underscores or double underscores after the name of method. Now the problem here is they are really difficult to announce. They are weird looking. So dunder is a short term that we use for them. Now in this term dunder, D is coming from the word double, as you can see here, and under is coming from underscores, so that makes dunder. Now these are called magic methods. By magic method, we mean that we do not have to call them explicitly. We can do that, but actually they have a special purpose and Python call them at specific instances by itself. Like we don't know, but they are called at the backend when we do certain things with our objects. Okay, now as I told you that we can call them explicitly as well. And these are public methods and we can call them from our code or from main program using that instantiated object as well. But Python has a special purpose or special execution time for them as well. Now, what we can do with these methods, we can override these methods, like we provide our own custom code, and then what will happen, since Python execute them automatically, so when they are executed, the code that we used in the overriding section, that will be executed. That means that we can alter the functionality of these dunders if we want, right? And why we need to do that? Actually, they provide many uses. Like they are used as constructors, which we'll be seeing shortly in the upcoming slides, and they are also used for operator overloading. Now this operator overloading feature, we'll be discussing this in most probably week 5, so let's leave it till then. For now, let's concentrate on this on this constructor part. Now while writing a code for that class fraction, the way we wrote it, I discussed an issue there that you cannot call that getter function before the setter functions, because setter functions are the ones where those instance attributes are actually created and initialized, right? So if you use them before initialization, then that would generate error in Python, right? So one solution to that problem is use of constructors. So first, I'll tell you what constructors are in general, and then we'll see how this concept is implemented in Python. Now, a constructor is a special type of method that initializes an object automatically when created. So what happens when you create an object for a class, this method is automatically called at the backend. So whatever code you put in this constructor, that is executed automatically at that moment, right? So what we can do here, that we can, if you want to initialize some instance variable, you can take the values in constructor as input from user, and those values can be assigned to that object's instance variable in the constructor. So that means when an object is created, you can initialize it to some values at the same time, like when you are creating it, right? So this will save you from calling those setter methods explicitly for each instance. Like we made 2 setter methods in class fraction, so and we had to call them one after the other to set numerator and denominator respectively. But once we start using this constructor, we won't need to call them for initialization purpose at least, right? And this will overcome this error also. Like since they are initialized at the time of creation, calling a getter method will simply return those initialized values, and it will not generate error anymore. Now, in conventional object-oriented languages like C++ and Java, um, a constructor can be identified by its name and its return type. So what's specific about a constructor is that a constructor has the same name as that of the class. Like if the name of your class is my class, then constructor should also have the same name. So whenever your compiler or interpreter comes across a method that has the same name as that of the class, that means that's a constructor, right? And a constructor, it does not return anything, right? So these are the 2 things by which compiler or interpreter identifies a constructor. Let me show you an example from C++. Now in this code, the first line is class definition, and it's almost the same as we do in Python. Okay, one special thing that I can show you here is this public. This is a keyword which is used as an access specifier in C++. I hope you remember from last lecture that languages like C++ and Java, they strictly implement this concept of access modifiers, whereas Python doesn't agree with that. So this is the keyword, and this is how they use it. Now public colon my class means this my class is a public method. And since the name of this method my class is same as that of the class, that means this is the constructor. And Python doesn't use any return type, but if you remember from the first week, the code we saw for C++, there we had return type also preceding the name of the method, but here that's missing. So that means we are not specifying the return type here, so it's a constructor. So this constructor has same name as that of class, and then there is some code that will be executed whenever you instantiate an object of this type my class. Now you see Python doesn't follow the conventional rules here as well. Like in access specifiers, Python did not agree with the concept. So here also Python uses constructors, but in a different way. We do not define constructors like we define them in C++ with same name and no return type. So what here we use this dunder method instead, double underscore init double underscore, and this method is automatically called, since it's a dunder, it's a magic method, so it is automatically called whenever you instantiate an object, right? And we can override this method because we are inheriting this method from that object class, so we can always provide our own code that will override uh, mm, uh, uh, this method from the base class, and that's how we can provide our own custom execution for this method. Now let me show you an example on this. Now let's define this initiator method for our class fraction. This was the class definition, and here I am adding this method, initiator method. So see, the signature is the same, double underscore init double underscore, and as parameters, self is the essential parameter because init is also a method, so self should be there. And then we are providing two values, x and y. These values will be provided by the user when instantiating an object, and these value will be assigned to our instance variables, right? So it's working almost the same way as our setter functions were, but the only difference is that this method will be called automatically upon instantiation, right? We do not have to call this method explicitly. Okay, the other methods, they are the same. I'm not mentioning them here to save space. One thing that you should note here is that the order doesn't matter. It doesn't, you don't need to define this init method as first method of your class. It could be anywhere in your class, right? Now let's see how we can use it or call it from our main code. Now this is my initialization statement or instantiation statement. F1 is equals to fraction, and in parentheses I am providing these two values. These two values, they'll actually correspond to x and y in that function init, right? In that dunder method init, right? So now you see we are providing the initialization values directly while initializing it, and we do not have to call those setter methods explicitly, right? Now let's test it by printing the results. See here I am calling this get fraction method, and I'm calling it without calling those setter methods first, because I'm expecting that these instance variables numerator and denominator have already been initialized through init method. I'm not calling init method in explicitly, but Python would have called it when this instantiation statement was executed. So I expect some output here. Okay, 33 and 100. These are the values that I initialized. Now you can always change these values using setter methods when you are working in your program. Like you see, I am resetting them to 4 and 10, numerator and denominator respectively. And now I print this fraction again. Okay, this is what I expected, 410 as a tuple. So that's how we can initialize, or we can use this initiator method as constructor, right? So the concept, if I recap it, the concept of constructor is that you call it to, actually you do not call it, it is called automatically by your compiler or interpreter, and its main purpose is to initialize the values, right? Now let's instantiate another object f2. Now, if you see in this statement, now I am instantiating f2 without any initializations. Now, do you think that Python will permit me to do this? No, this statement will generate error because f2, when I initialize f2, that init function will be called again, and if you see that init function, I have overridden its original functionality. Originally it was allowing me to call it without any arguments, but after I have overridden it, we know the rule for overriding from lecture 1, that whenever you override a method, then overrided implementation executes every time, right? So whenever from now on, whenever you instantiate an object of class fraction, this my own init method will be called. So this init method requires two positional arguments, which I am not providing while instantiating f2, so that's why it's generating error. Now let's see how we can solve this problem. Now first let me tell you what other languages follow. The problem in the code that I showed you on last slide was that f1 was initialized using those two initialization values for x and y, right? Whereas I was trying to initialize f2 without any initialization values. So the other languages, what they do, they overload the constructor to provide multiple implementation to suit various needs. So now let me just recap the concept of method overriding and method overloading for you here. Method overriding uh, happens when you implement inheritance. Like there is a parent class and it contains a method, and then in child class you redefine that method. This is method overriding. So when you override a method of parent class and then you instantiate an object of that child class, the new implementation always gets executed, right? The previous implementation, it becomes void for the objects of that child class, right? This is method overriding. So the important point here is that the two implementations of the same method, they exist in different classes, one in parent class and the other in child class. Whereas when we talk of method overloading, all the implementations of a method, they exist in the same class, right? So what kind of support does it provide? That you can use the same method for different data types or for different number of parameters. So what other languages do, they provide multiple constructors. Like there could be one constructor with let's suppose if we are talking about that class fraction, there could be one constructor with two values for initialization. Then there could be another constructor having the same name, but it does not take any parameters, so that f2 initialization will not generate any error. And then you can have as number of implementations for constructor as you feel like, right? But in Python, we know overloading, method overloading is not possible. Whenever you define methods of same name in the same class or in same namespace, what happens? The latest one always gets executed. The previous one or all previous implementations, they become void, right? So that cannot be applied here. But Python provides an even easier way for handling this problem. So what we'll do here, we'll use that technique of using default parameters. I hope you remember that from CP. This is how you define default parameters. Now in this statement, x is equals to 0 and y is equal to 1 means that if the user passes some value while calling this method, those values will be assigned to x and y. And if the user is not passing any value for these parameters, then these parameters will take these default values, right? Now this frees us from the burden of passing x and y parameters every time. Now after defining this, uh, 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 we have a choice now. Like in fact, more than one choices. I can pass two parameters x and y to this method. I can pass only one parameter x to this method, or I can pass even y parameter alone, and I can call this method without any parameters as well. Now the rest of the code remains same, right? And let's test this functionality quickly. This is what we had been doing previously. F1 will be initiated to 33 and 100. That means numerator will be 33 and 100 will be the denominator. Let's print this to check. Correct, right? Now if I instantiate this another object f2 without passing any parameters, what will happen? Default values of 0 and 1 will be assigned to numerator and denominator respectively. So here if I print this, I expect a tuple of 0 and 1. So here it is. So see, this default constructor, it can save you from defining many copies of constructors as we do in other languages. Now, before ending this lecture, let's discuss a similar concept, destructor. Actually, it's a paired concept. Whenever you talk about constructors, you talk about destructors as well, right? So let's see what destructors are. Destructors actually perform the reverse function of that of constructor. Like a constructor initializes an object, it defines an object, it allocates memory for an object, whereas a destructor cleans up the mess. Like after you have used an object and you want to remove it from memory, what you do, you call a destructor, right? So what does it do? It deallocates the memory, and it also releases any resources that has been allocated to an object. For example, if you are opening a file in some method of that object, then it's the job of that destructor to close that file while destroying that object, right? So basically it frees the memory, and it does the cleanup task. Now, what happened in older languages like C++, um, a programmer had to call a destructor explicitly before exiting the program. Like it was the job of the programmer to clean up the mess. Like if a programmer has instantiated certain objects in the program and memory has been allocated for those objects, then a programmer had to free that memory before exiting, and that could be done using destructors. So this is a sample code from C++. Again, you don't have to dwell on the syntax much. What I want to show here is that my class is the name of the class, and this is the constructor as we discussed in previous slides, and this is the destructor, right? And what's the difference in both of them, apart other than functionality? The way they are defined, that tilde sign before my class, that means it's a destructor, right? So the point here is that whenever a program was written or is still written in C++, it's the job of the programmer to call this destructor for every object that has been created in that program, right? But the modern languages like Java and Python have a better solution to this. Now let's see what that is. The same job of destructor is done by garbage collectors in Python. And what is a garbage collector? A garbage collector is a program that runs to recover memory by deleting the objects which are no longer in use or have finished their life cycle. So basically, this does the job of destructor, but the different thing here is this, that we do not have to call this garbage collector explicitly. Our program calls it periodically and cleans the mess along the way. So these are the advantages. It provides automatic memory management, like it frees memory when it is no longer needed, or it removes the objects when they are no longer needed. And how it determines that an object is no longer needed? When you remove all the references to an object. Like we know that whenever we create an object, we link it to some variable name, and then we use that variable name to access that object. So once this garbage collector finds an object which is not linked to any variable name, it simply destroys it, right? Okay, this is the point that I told you earlier, that this garbage collector, it does the job of destructor, and this is its speciality, or the difference from that explicit destructor calling in C++. It is called automatically after some time, or when your program finishes. Apart from Python, Java also uses the same mechanism of garbage collection. Okay, now this is what I've already told you. Python's garbage collector runs during program execution and is triggered when an object's reference count reaches to 0. Actually, reference count is the number of variable names that are linked to that object. Let's suppose x is equals to 3 and y is equals to 3. That means 3 has been referenced by 2 variable names. So the reference count is 2. So if I change y to some other value, reference count becomes 1. And then I change, let's suppose I am changing x to some other value 2. So then reference count to 3 will become 0, right? And in that case, garbage collector will find it, useless and will destroy it. In a program, you can also explicitly delete an object. Like Python does that by itself when your program ends. But if you want to explicitly delete an object, you can also do that using the keyword del. Now I've written it in green because it's a keyword, and then you simply write object name, and then this keyword, it forcefully deletes an object from the program. I'll show you example of this shortly. One important thing here is, whenever you delete an object using this keyword del, it automatically calls another dunder method, and that dunder method is this del, and double underscore del double underscore, and it is always called whenever you delete an object, or an object is destroyed. So if you want to do something, if you want to print something, or you want to perform some extra task when an object ends, let's suppose you want to write it to a file, or before destruction, then you can do that in this method del. Right, now let me show you some examples. Okay, now let's define that dunder method, that second dunder method, double underscore del double underscore here. Now initializer remains the same as before, and this is the definition for my new dunder method del double underscore del double underscore. And let's suppose, let's print some statement here. So these are the last words of my object before destruction: goodbye everyone, and the remaining code remains the same. Now let's test this. What I expect here, that if I instantiate an object, and then I call that del operator to delete it, then this del dunder should be called automatically. Now one thing that I want to highlight here is that this del method, you are not overriding this method from that object class. It was not defined in object class. You are just defining it from the scratch. Like, this is the first time you are defining this method in your class, right? It's not there in the parent class, I mean, right? So let's see how it works. Okay, I have instantiated first object f1 to 33 and 100. 33 is the numerator, 100 is the denominator. Let's print this on screen. We already know this, right? Now let me delete this object. Now if I execute this statement del f1, now here this del del is a keyword, and this will destroy this object f1, and whenever an object is destroyed, that dunder method del is called. Right, now you see the names are same, del del as keyword and the name of my dunder method, but they are different things. Dunder method is a method, right, and its name contains those underscores also, whereas this del in this third statement of test code is just a keyword, right? So whenever I try to delete this object using this del keyword, what will happen at the backend? Python will call this dunder double underscore del double underscore method automatically, and when it is called, this statement goodbye everyone should be printed at the output. So here it is, right? And now I can see if f1 has actually been destroyed or not. What can I do? I call some method, let's suppose on f1 I'm calling this get fraction method for f1. Now this time, since I have already destroyed it, so if I call this after destruction, this statement will generate error. See, so you can delete an object whenever you want in a program, but you don't have to do this, because this task is automatically done by Python for you. So you just do this if you really need this, or you actually know that you need this. Otherwise, do not interfere with this process that Python runs automatically. Okay, that's all for today. Uh, this is what we did. We saw how directory function can be used to list attributes and variables of a class. Actually, when you define small number of attributes, then it's easy to remember them. But for large classes where you define a number of attributes and methods, this function dir, it comes really handy. Then we talked about dunder methods, that what are they and when they are called and why they are called magic methods. And then we discussed two magic methods. One was this init method that is used as a constructor to initialize objects, and also that del method, which is used by garbage collector of Python. And garbage collection simply means that your objects, they are destroyed and the resources are released when they are no longer needed. Thank you.